Hello. Uh, okay, cool. Um, Wait, how do I get to the link of the stream? Damn, okay. The stock image is pretty funny. Okay, I'm gonna like copy paste like the link into my phone so I can, in case anyone actually watches and like the chat is active or whatever. PD6GXSDDOS. Wait, I can't even see chat on my phone, so it's like it doesn't work. What the hell? I also don't want to like periodically check. Like I want to know if someone actually watches. Um, Maybe if I turn it sideways. God damn. Okay, this is not gonna work. Yeah, there's got to be a place where you can see chat. What? No. Uh, YouTube stream. How to see chat on phone. This doesn't help. Man, is there a way to like Wait, but is it redundant if people just see chat twice? Like I guess like scroll to here where it's like only chat. But like it's stupid because then I'll be like viewing the problems in like another browser window, so it doesn't even work. Ah, fucking. God damn. There's legitimately no way to like view chat on phone. Is this like so stupid? Oh, maybe I need to sign in order to see chat. I don't know. But you should be able to see it regardless. No, if I delete the video, then I have to like I have to re-upload the thumbnail. At this point, I just like don't care anymore. Where did the link even? Okay, here it is. Okay, I guess I'll just check periodically and figure it out something else. Because like, who knows if anyone's even gonna watch? Um, hmm. I'm like deliberating over. I don't know why I'm nervous. No one's even gonna fucking like see it. Yeah, so sometimes I feel guilty about like everyone pinging like everyone in my server, but like then I feel like then I remember that like they joined it like voluntarily, so like they can like opt out at any point if they like get annoyed. So I feel like ethically, pinging 103 people, especially when it's my own server, is okay. Okay, perfect. Yeah, yeah. The stock image is like huge. Nice. Okay. Code Forces round 788. Um. Okay. 15. Yeah, sure, it's fine. I'm gonna like periodically check, like refresh this to see if like the viewer count exceeds one. So far, I don't think the viewer count has exceeded one. So damn. So sad. But see, I have the illusion of someone watching me, so like that makes it more pleasurable in and of itself. Or no. Hey, Professor Slim. Okay, we skip the story because it's more than one sentence long. Its elements are arranged in not decreasing order. I read through the entire problem and I don't know what the problem is. like, okay, you have some operation, but like, what's the? God, because I'm streaming, I feel like I'm like obligated to like talk all the time. But like, I feel like, God, that's just not possible. Wait, are you trying to find the minimum number of? Oh, I think it's just check if it's possible. Okay, I see. Um. So I think a necessary condition is that, like, if you were allowed to, um, if you were allowed to assign signs arbitrarily, then there would need to be some way to sort it. Um, is it true that the number of yes, I think the number of like plus signs and the number of minus signs is like invariant. Okay, yeah. So I think the solution is to so you know that the number of plus and minus signs is invariant. So some prefix of the array is just gonna have like be negative, and then you just check if it's sorted or not. Are they distinct? So I guess it doesn't matter. Okay, yeah. Pog. I think this is a pretty good A problem. It's like very clean, I guess. Um, damn. Do we have to be careful about elements being zero? No, I don't think so. I mean, zeros are just like effectively like positive, right? Actually, oh, hold on. Wait, this is kind of oh, none of the integers are zero, so it's okay. Uh, And for the first minus things, um, and then you just check whether it's sorted or not. No, yes, yes, no. Cool. I feel like this is kind of hard for A, actually. It's it's a pretty good, easy problem though. Yeah. Okay, 1120. Okay, I fucking suck at CP, I guess. Dorm's War. People are solving D already. Interesting. Okay, is anyone watching my stream? No, it's a fucking trash. What? I thought like, goddamn. Like I don't know if there's like a random link to a stream, like I would click on it probably. Boom. Whatever. It's still slightly more fun than just being alone. I guess. He already knows the password. String of length n. There are k special letters of the alphabet. All positions I, such that si plus 1 is one of the k special letters. Then it deletes all of those positions from the password s, even if si is a special character. I feel like I'm having a fucking like aneurysm. Like I don't understand. What? Okay, calm down. 1 and 3 will be deleted as they come before special characters. It deletes position 1, which becomes df. If he is wise, he won't run it a third time. The sound of the... Wait, what is the problem that you have to do with the integer n? I see, okay. So there's a string s of length n, which is an object in like the outer world, and the program takes as input some generic string of length m. I see. Okay, so you want to count the number of operations it takes until the string does not contain any special characters. So I guess like you could imagine that initially the string has some special characters and there's some like gaps in between them. Is the answer the length of the largest gap between two special characters? Between two consecutive special characters. Well, what happens when say some special characters are next to each other, can it be treated as if it is just one special character? Hmm. Oh, I'm tired. So if you have some segment of special characters, then all of them get deleted except for the last one, right? Uh, yeah, so effectively it's as if only the last special character in that segment existed. So I'm pretty sure it's the length of the largest gap, right? Because like the size of the gap only decreases by most one. I mean, like it'll decrease by like the size of the largest gap will decrease by like, and there will always be a special character before and after that gap, and every single other gap. I don't know. I mean, it's like cancerous to like formally prove, I guess. Um, I love. Oh, I guess. Yeah, I guess it counts the first and like last. So the answer here should be like maximum of 5 and 3. Yeah. Um, is it really true that the length of it decreased by first one? So the current answer should be a lower bound. How do you prove that's an upper bound? Um, I guess every other like gap gets like wiped out faster, right? Wait, what happens if it's just a single character left? And yeah, what if there's a single character left and it's a special character? Is that possible? Yeah, for sure. And then what's the answer? Infinite? God damn. Is there any test case where all of there must be some constraint that like prevents that from happening or something? Oh no, never mind. I'm stupid. If then I just close this out. Yeah. Uh, so I think what I previously said with the answer is correct if there's at least one non-special character, but if all of them are special, then I think the answer is 1 if the length of the string is bigger than 1, and 0 if the length of the string is 1. Sounds right. Well, I mean, if all of the letters are special, then what I said is correct. But Wait, there's something. Now I think that. Uh, wow, damn, this must be like insanely boring to watch. Okay, I thought I'd like speed through the like first few problems at least, which was entertaining. I don't think anyone's watching anyways. Okay, yeah, no one's watching, thankfully. um, let's say that the first and last characters are special or something. So then, from what I first said, this would take this actually takes two operations, right? Ah, so maybe you add one to the answer. Oh. But then if it's like or like A B where like the last character is special and like okay, maybe there's a dumber way to solve this. Because like, it feels like it involves some like cancerous casework. So naturally, a natural question to ask is, can you simulate it? Um, I mean, it's very hard to like perform the option, perform the operation like remove a character from a string. So maybe not. Maybe you just have to do the cancerous casework. But I don't know. I don't really want to think about it. It's like I don't know. Okay, no, I think there's a better way to think about it. Like at any point the string has some gaps, right? Like gaps of letters, or like basically contiguous segments of characters which are non-special. So for the first and last gap, um, like they'll necessarily like they'll like decrease by one on every operation. But if you like something in the middle, then I mean it also decreased by one in every operation. But then like if it's a gap in the middle and like it disappears, then like there's like two there's necessarily a special character after where the gap was and like a special character before the gap. Um, so then it'll take like one more operation. But then for the starting and ending ones, like I think you don't add one because but it seems very iffy though, because it's like it feels quite cancerous to prove. Oh yeah, no. The solution seems correct. Yeah, you consider all this like contiguous runs of non-special characters, and for the anything in the middle, you add one to it, and like for the first and last ones, you don't add one, I guess. Ah, but it's so hard to prove. I think you can prove that all of these things are indeed. Yeah, okay, you can prove that this is lower bound. Yeah, but then you prove that this is an upper bound somehow. So maybe there's two cases. Either there's something in the middle or there's something not. Okay, so let's consider the one that contributes, the segment which contributes maximally to the answer. Then it's either in the middle or like at the edge. So suppose that it's at the edge. Then indeed the answer should be less than or equal to it. So I think that case is easy. Alright, so suppose that it's at the edge, then like after you do all those operations, it necessarily must be true that there's like no segments like remaining, and it should also be true that there's just one character left. I think that's correct. Otherwise, if it's in the middle, then uh, then once you like delete the shit in the middle, then there's going to be one thing on the left and one thing on the right. But all characters should be special at this point. Otherwise, there exists some like segment of special characters that hasn't completely gone away yet. So I think that case is easy to prove. I think my proof for the first case is kind of scuffed though. Does this require some inductive or anything? God, it's 1:36 and I haven't submitted B. This is like such a disaster. um, you just need to prove that after you in the case where the maximum contributing segment is like the first one, for instance, then there's only after like you delete all of that, there's exactly like one non-special character. There's exactly one special character which remains in the string. Oh, also, I think I implicitly assumed that there was at least one special character somewhere, because like if none of them are special, then the answer is also just zero. Yeah, that's actually in this particular case. So we can assume that there exists another special character. Um, and we know that the rightmost special character never gets deleted, so there definitely exists at least one. There's not more than one. Suppose that there's more than one. Then consider the gap like in between them, I guess. Consider the last state the string was in, where there was at least one non-special character in the segment that wasn't the first one. God damn, this is so fucking... I'm just gonna cut it. I don't know. I feel like... I don't know, if this solution is correct, then this problem's like a huge, it's like a huge proof gap, where like the proof of correctness is infinitely harder than the problem itself. Than like thinking of a solution to the problem. Which is just like really annoying. Let's use set for convenience. Uh, Wait, this, I think you need to start at -1 for it to be correct, maybe? The invariant on I is that I always points to a, like, I always starts at a, special character, and then you want to get, like, the length of the segment until the next, like, end one. I think it makes sense. I don't know. Almost too hard. Well, first of all, this is if all the characters are non-special, and you can't ever do anything, otherwise there's at least one special character, and we can proceed. So ugly. Okay, I mean, I'm pretty sure this is correct. I don't know. I don't know, maybe I'm just bad at proving things. Despite like always wanting to prove things. It's a legitimate like mystery. Did I read in the string? 52251. 522. Oh my god. Wow. 523. S and I. Okay, so my implementation is wrong, I guess. Interesting. Why would the answer? Why would you output 2 instead of 3? Stupid program. Because there should be a EI. There should be a 0 at the end, right? Because I should point to here and then it should push a 0. God. This is a absolute disaster. Two. SI, right? Wait, why? Why is there not at least like 1 0 in there? Makes no sense. Oh, it's because it skips some stuff before I do this. Damn, stupid. Okay, 523 510 510 3520 352. What? Didn't I Oh, I see. I guess I mean I know this is the case where there's no wow, 2,000 people. That's insane. Um no, this is like my worst round I've ever done. Holy shit, is anyone watching? Oh, thank God. No, I legitimately think I'm gonna delete this, like, after unless I, like, somehow AC this problem, and then, I don't know. Because the thing is, like, I could, like, somehow, like, monkey patch this, right? But it somehow, like, indicates that my proof is wrong. Or, like, I don't know, it could legitimately be a special case, or I could have implicitly assumed that there was a, like, letter, um, or maybe my program's correct if, there's, like, there's a special character that's, like, not in the first position. But, like, regardless, it just feels like I'm just proof by saying at this point. Like, Hmm. Well, I mean, a very elegant way is to wait. Is it still the case where like all of them are special? Sure, right? Because equivalent, you can just like force like the first one to not to like be non-special, right? So, well, it's not special, or it's the first one, I guess. I mean, now it's correct, but like, I mean, it could be true that like we can notice that like the samples are like very strong here, right? So like, somehow like that is related to the nature of the problem, I guess. But still, these are like random tests. They don't have a A, B, E, H, I, O. Actually, this is a test where. So it seems like they intentionally made samples to be strong and like catch out solutions which would fail in certain cases. So maybe it is just a case of problem. I don't know. I'm gonna submit. It's like the fastest way to like disprove the solution if it's incorrect, I guess. I mean, even if I got AC, it like it doesn't feel like good, right? Yeah, no. Okay, no. I must be like it must be like much easier than making it out to be. There must exist some easy provable solution. I think initially contiguous segments of special characters can be like merged into one character maybe. Um, and then because it's like effectively the same, right? Because the effect is that well, you also still treat the first character as always being non-special. Wait, I think I'm stupid. The last the last like segment doesn't mean anything to the problem. Yeah. Like if there's some special suffix of non-special characters, then they can just be ignored. God, why? Hmm. Whatever. I mean, I actually think it should be correct though. For some reason, like, I don't know. I still feel like there should be something better. I don't know. I mean, whatever. That doesn't really feel that good. Is anyone watching my live stream? No. CI is equal to AI or CI is equal to BI? Oh, okay. I see. Interesting. Are they both of length n? Yeah, they are. Um, alright, so you pick one of the two. So if AI is equal to BI for any I, then like you just forcibly like pick that one. Um, okay, so if we like make a decision to like let's say the first number of A is one, the first number of B is one, then if I mean if they're like different, then if you pick one of them, then this like implies some position in the well you can't pick one again, so this implies some other position where you have to take so you do some type of swap, right? So this encourages drawing some edges, I guess. Where do you want to draw the edge? So if you pick one thing, then this implies that you pick another thing, I guess. And eventually you must pick a bunch of things until you get back to the beginning. So I think it would help to... Wait, what? What is the input of 3? Did I... Huh? Oh, and okay, so they just made the problem harder by including a third array. Cool. Um, it's just allowed to be all zeros, right? Yeah. Okay, so for example, here if you pick this one, then it implies that you necessarily also must pick the 3, which implies that you must pick the 2, which implies that you pick a 1. So 1, 2, 3 are like sort of connected in some sense, I guess. Where if you pick any one of them, then it implies that you like pick the entire thing. So we can notice that like for each of these like components, it's basically like some type of like I guess sub permutation, and it looks like the answer is yeah, 2 to the number of yeah, 2 raised to the power of those things. I think the answer is always a power of 2. Okay, cool. Yeah, so I see. Yeah, yeah. So basically, the numbers that you're given, they'll occupy some of the connected components, and yeah, they'll occupy some of the connected components, and the connected components which aren't occupied, each one of them multiplies the answer by 2, I guess. So you care about the number of like distinct components that the numbers below occupy, I guess. Like here, if there's an edge between 4 and 7, and if two numbers are the same, then it's just like a connecting component of size 1, basically. Oh, but then you can't, yeah, you don't multiply the number by 2 if the connecting component is size 1. It's kind of annoying. 4, 5, 6, 7. Yeah, there's an edge between 4 and 7, and 7 goes back to 4, so this is another individual thing. Yeah, I see. So more formally, you draw an edge from I to, the second thing you want to keep track of is like the index of I, right? Wait, are we drawing edges on the indexes or the actual like labels, I guess? I think labels is more convenient, right? Okay, cool. Yeah, I think it should be correct. Modulo is what, 29%? What am I doing? Actually, you can just, because there are a bunch of like cycles, right? So it's very easy to. No, thinking. What am I doing? Um, um, should be A of the IDX. So yeah, right. Next is not equal to AI. Then you repeatedly do this, and I should fill everything inside the cycle, I guess. Um, if scene of V is what the fuck am I doing? In V C scene V. I think the answer should be 2 to the current at the end of this. It's just the number of like connecting components that haven't been seen, I guess. Hard to explain. What? What is wrong with this? Oh, here. I see. Oh, right, but you don't count it if it's like size 1, right? Wait, but if it's size 1, then it's in fact guaranteed to be visited, right? Well, actually, if it's 0 and you don't know, okay. So we can just do an extra check. But this requires, yeah, so effective. What the fuck am I? Otherwise, if AI is equal to BI, then you count this component as being visible because there's only one like C that yeah, makes sense. Huge sample actually. Oh, awesome. There's an infinite loop. Is that even possible? Okay, but what number does next get stuck on? Well, next is not equal to AI. Isn't that what I put? God fucking... Yeah, why? Okay, it's stuck at 1, which is... Holy shit, please. Why would it ever be... in the first test case? Yeah, okay. Holy shit, please. Why would it get stuck at 1? You get the index of 1, which is 3, and then you get, I mean, which is 2, I guess, and then you get a of 2, so it should turn into, so this implies that a of idx of, isn't this what I want? I feel like this next variable is poorly named. It should be called like cur or something. That cur is already used. But yeah, you find the index of the current thing, and then you find what's at that index, and then there necessarily must be a cycle. Yeah, I guess every... Well, I haven't proved this, but I mean, it should be true that everything has in degree 1 in the whatever graph that I'm thinking of in my head. 2, 1, 2, 1, 4, 8, 16. I'm gonna fucking kill myself. Let's just copy the first one. Wait, what? Oh, I didn't compile. 145. Isn't that right? Yeah, so there should be three components, right? Oh, it's because I never, okay, I see. It's a small bug, because I never, should be equal to curve. Oh my god. It's like, it's like hard. I don't know. There's still a 16, which is awesome. In the second to last test case, it thinks that, it's just 8 apparently. Which is which is like actually so random, right? Because why would it be 8? There's like 5 elements and they're all, oh, never mind. The answer should be 2. Yeah. Why 8? I don't understand. It legitimately makes no sense. Oh, but okay, there we go. How am I feel like I'm making like a ridiculous amount of mistakes. It's not good. 41221812. It should be correct, I guess. It's not really okay. Maybe n equals 1. Seems like n equals 1 is already here. But like, I don't know, the amount of mistakes I've been making is like really ridiculous. And it's just like, it feels like it feels hard. Like it didn't used to feel this way. At least n equal out, right? So it's an infinite x7 grid. Okay. Interesting. Uh
some samples. 1, 2, 3. It's 83. Oh, okay. So you can it's kind of hard to like wrap your mind around what a single line accomplishes. So 3 lines you can create 6, right? So I mean, obviously you can always create double the number of lines of triangles. So equivalently, you're always cutting some hexagon in half, right? In fact, like an infinite number of hexagons are getting cut in half. But how many like unique slopes can you? One, two, three. So you can have like 3 different cuts, right? So let's examine some fixed hexagon and like see like which like cuts are. There's 3 different possible cuts, right? So with one cut, you'll never have any. With one cut, you'll never have any triangles, right? With 2 cuts, it seems like there's always so with 3 cuts necessarily there are 6 triangles from this one hexagon, right? Um, Alright, so back to the old idea. I think 2 cuts won't necessarily create. Yeah, it's true. Two cuts won't necessarily create 2 triangles. Yeah, so for each hexagon, we just count. We just care about like the number of cuts that like go through it, I guess. It's like I don't know. It was really hard to visualize. So I think for any two lines, they can only intersect at one hexagon, right? But is it possible to somehow make all the lines? So there's like three classes of lines. Like some lines go this way, some lines go this way, some lines are like horizontal. Obviously, you never make the same cut twice. Um, and lines of the same class are parallel, so any pair of those lines won't ever they won't ever like intersect at some hexagon. Wow, thank God for this diagram. Probably very impossible without it. Need some potato chips. Man, I'm really hungry. Oh. I feel like none of these observations really none of the observations that I've had so far really help that much in solving the problem. I mean, like they're good, but like I don't know. Oh, wait a second. I think or like you care about Oh, I see. Okay, so I'm pretty sure the number of lines will be like basically square root of n. Because if you have any two lines that have different like orientations, they're gonna intersect at some hexagon and contribute at least the two rectangles. So you just kind of care about like the number of hexagons such that there's like three intersections. Okay. Damn, my apartment is like in desperate need of like more food. Now live on my channel, school is gone. Anyway, so you kind of want to having like three lines intersect is like very. Oh, I see. Oh, wait a second. That's very cool actually. Um, because I think the only thing that matters is which because when three lines intersect, it contributes six, right? So equivalently, that's equivalent to like any pair of the two lines, like any pair of the two lines contributing two. So damn, yeah, this problem is really fucking good. Uh, so only the number of like horizontal and these two things matters. And okay, so let's say you have A lines of one type, B lines of a second type, C lines of a third type. Then it's so it's AB plus AC plus BC, right? Times two, I think, right? And I think in order to, and your constraint is on A, B, and C. So I think you want to make them like as close together as possible. Um, since suppose that like there exists two elements such that like their absolute difference is strictly larger than one. Without loss of generality, suppose that this pair is A and B. So A is let's say that A is more than one larger than B. So yeah, we can factor out A plus B here, right? Oh shit. Yeah, we can factor out A plus B here. Right? Yeah, this is A plus B times C. Lowering A by one, raising B by one, this thing remains invariant. So all that you've done is made these two things closer together, and then yeah, that's so that obviously increases the number. So yes, it's proof that we want to like make the numbers as close together as possible. So yeah, okay, yeah, that solves it, and this will take like square root time. Wait a second, there's a problem. There's 10 to the fifth test cases. But you can just store these in a vector, like binary search or whatever, right? So you pre-compute it as long as it's um can the input be zero? Um, um So it's a times b plus b times c plus c times a times 2, right? Wait, I completely forget what standard lower bound does. It's the first element that's bigger than or equal to. Yes, it's bigger than or equal to. So that's exactly what you want. Um, if canned exceeds this. You want bigger than or equal to n triangles, right? Um, I think we should start at 2 and then because then it'll like all the values inside the split will be distinct, and the thing that bigger than or equal to it is legitimately like the minus begin menu plus 2, I think. I mean, if it's incorrect, I think it'll be. Because with one line, it's the same thing as 0 lines. One line's just useless. Or actually, even with one, it's still. It would have been correct if I didn't. Okay, thanks. I don't know what I'm saying. 223, 83. Good. This is safe, right? Because you just need one thing that's strictly larger than 189. Yeah, that seems right. Plus plus b plus plus. Yeah, I mean, seems correct. Yeah, I can only really go wrong for the small cases, which are basically already checked. Damn, that took 21 minutes, and B took me 33 minutes. So it seems like B was the hardest proof. Stupid. Oh, F is easy this round. Weird. Oh yes, construction. Should select some root for the tree, such that the maximum cost of any simple path starting from the root and ending at any node or edge is minimized. What does it mean, ending at any node or edge? Node and edge and integer. Oh, I see. 1, 2, n minus 1. Because there's n minus 1 edges and vertices. Any node or edge is minimized. the XOR. So you want to minimize the XOR. Okay, I see. N is a power of 2. So this means that 2n minus 1 is 1 less than a power of 2. Cool. Okay, so you have to explicitly output the construction. Interesting. Usually a classic idea with like XOR on a tree and like paths is okay, never mind. Here all paths already start from the root, right? What if we binary searched on the maximum value? Maybe not. It doesn't make so much sense with XOR. It's kind of difficult. I think we want to think about bit by bit. So we go from the left, and I don't know whether the first bit should be part of the maximum value or not. We want to find some arrangement of things, I guess, such that actually, how do you even prevent that, right? Because eventually the first bit needs to be turned on, right? So necessarily, whatever like the highest bit is, that the minimum thing is going to be greater than or equal to that. So because this is competitive programming, naturally you might suspect that the minimum maximum XOR value is indeed equal to the highest available bit, because that's a lower bound, right? So how do we ensure that? So basically, whenever that bit gets turned on, you want it to be you want it to be like exactly equal to that bit. Hmm. But anyways, the passing is very strange. The root also gets assigned a value. Yeah. Oh wait, the problem specified that you could root the tree anywhere as well, right? Why would changing the root allow you to? I'm still convinced that this is the answer. There's n vertices and n minus one edges. So something very, very special like about this condition, right? I feel like you kind of want things to like alternate. Can you it feels like you want the first bit to like flip on and off. Yeah, you want to like flip on and off as you go down the tree, I think. So let's say we're at one. What is let's say the root is one. Then we okay. I mean, it kind of makes sense that you want to root the tree at n actually, because like n is very special. I don't know. um, the problem is two. How many numbers are between n and 2n minus one? This is a stupid question. I think it's n, right? Yeah. It's n. So yeah, but really tree at n, like numerically, it makes sense in terms of like guessing the answer. Um, okay, so we can then pick some arbitrary edge, maybe. Um, I don't know. The thing is, what do you want? I want to flip this bit and then. No, it doesn't make sense. No, we root the tree at n, excluding the root, the number of vertices. It's both n minus 1 for both quantities. So yes, it does make sense. So yeah, we want to pick some arbitrary edge in the range n plus 1 to 2n minus 1. And then that'll flip the bit and then it'll make the value like whatever, right? And then somehow we want to get back to n, maybe. Except then that would require so annoying. Like, you know, in order to come back to n, you need to like use the same value again, but you're not allowed to do that. So maybe you want to pick another thing that's smaller than n, and then I think I might have a construction if what maybe I don't know. I think it does work. Maybe like you start at some vertex with n, and then you have some value with which flips it, and then yeah. So n XOR this edge is some random value smaller than n, and then this is some random value that's smaller than n. And then I think this edge should flip it back to n, maybe. So it's like one. Less than n, still n, less than, goddamn, n, less than n. What the fuck am I saying? This thing flips it so that it's less than n. This thing is still less than n, so after this it's less than n. Uh, and then this thing is, makes it larger than n again. This thing makes it exactly n again, right? And then this thing makes it. Okay, so previously the idea was like less than n, larger than n, less than n, larger than n, and then you alternate it, right? But I don't think that works, right? Because larger than n makes this thing less than n, less than n makes this thing still less than n, larger than n makes this thing exactly equal to n, less than n then makes this thing. Yeah, so it doesn't quite work, unfortunately. Um, Maybe if you like flipped these two signs, like larger, less than, and then less than larger, less than larger. Um, hmm, I mean, it could work. I think XOR might have some bijective property where, like, I don't know. I mean, CCs is not dangerous, to be honest. So larger than n flips the parity of the bit, right? What's so good about flipping the parity? But when you flip the parity, you have to like immediately flip it back. Yes, I think whenever you or when you start at n, it's maybe okay, but no, there's no other like value for the root other than n that mathematically makes sense. Because I don't know, it's just more beautiful if you like, right? Okay. I mean, sure. Let's literally solve the problem for a straight line, right? Another special cases, the special thing is that there's number of vertices very particular. I'm not sure if we can solve this. Oh my god. Wow. Yes. Michael. Okay, yeah, I mean, yeah, it's naturally we want to solve the tree for bamboo first. Um, you are noticed. Wait a sec, how come it still says one watching now? Okay, so maybe the watch counter is just inaccurate. I don't know. Because I always assumed that the one watching now was myself, but because you're here now, there's for sure at least two people who are like on the stream page. I don't know. It's very strange. Uh, anyways, this problem is looking like fairly doomed. Why can't I solve it for even a bamboo? I'm like convinced because like the sample is the answer to the sample is 4 and n is equal to what? n should be equal to n should be equal to 4, right? Wait, am I stupid? What? 1 2 3 4. Yeah, n is equal to 4. That's right. Why though? Why is this construction seemingly... Okay, let's try small cases. Let's try n equals 2. So now we have the values 1, 2, and 3. So surely it should be possible. We start at the number 2, and then we go and, oh, we necessarily need XOR by 3, right? Because if you XOR by 1, we... Right, so 2, 3, 1. Yeah, that's valid. Yeah, the answer for that is 2. Okay, well, what's the next power of 2? 4. Bamboo on 4. So 4, um, is there any, like, DP on tree idea? I don't know. One, two, three, four. Yeah. Wait, I'm stupid. Why did I draw 3, No, what I meant to draw was this. 2, and then this thing has weight 3, this thing has weight 1. Okay, well, I mean, it seems to be good. Why don't we try, because we chose 3 here. It seems natural to pick 7 here. I don't know. 1, 1, 1, right? Um, so we're basically trying to find some sequence of numbers such that among all prefixes of the sequence, the XOR is less than or equal to n. Why can't I construct this? Too tired.
You're not gonna watch me solve anything, because it's so doomed. What if the root is not supposed to be n? No, there's no way. Alright, just pick like random numbers here. Okay, fine, 3. Now the XOR is 0, right? So what do we do? Um, I don't know. Let's put a 1 here. Now the XOR is 1. So what will get us to 4? This will get us to 47315. What numbers are we missing? 2 and 6, right? So this number can be 6. This number can be 2. Huh. Why did it feel that easy? Is there some like pattern I inadvertently created? I don't know. It doesn't seem like pretty at all. Hmm. This doesn't even help for like solving it on a tree, I guess. Oh, I really don't know. I know. I mean, when you get stuck like this, you're not supposed to. You're supposed to think of some like other idea. Like it's bad to like keep thinking about one idea and then you just like stay there forever. Well, I probably made that mistake many times during this contest, but like in this problem, I feel like for sure it's the correct path. So I don't want to think about something else. I think the constraint 1 to 2n minus 1 is kind of annoying. It'd be nice if there were a 0. Okay, but anyways, it seems kind of natural to like try to pair numbers up, I guess. Like you try to pair 1 with n plus 1, 2 with n plus 2. Because, I don't know, it's just a bunch of pairs of numbers whose XOR is equal to n. So, why would that help you at all? Like, what if you did n plus 1 over here, and you went 1, and then you did 2, then n plus 2. Oh, is that it, actually? Wait, no way that works. 4x, or I think the order should be reversed, but n plus 1 should be here, then 1. n plus 1 and then 1 brings us to 0, and then, oh, then maybe you flip the order, and then you do 2, then you do n plus 2 over here. 2 and then n plus 2, right? And then you're back to n,
and then you just alternate in that pattern. Oh my god, I don't have time to implement it though. So sad. Oh, it's so easy. I'm pretty sure I thought about that construction. Like at the very beginning, but it was like deep hidden in my subconscious. I would have had time to implement it if I didn't like brick for. Oh my god, my rank is 1,000. So terrible. Um, what happened to geothermal, bro? Um, if I didn't spend fucking like 40 minutes on B, then I would have time to implement this. Anyways, okay, for the I think for the general tree case, you root it at n, um, and so you pick some arbitrary root. It doesn't matter. Yeah, you root the tree at n, and then you just like DFS through it, and you always I think you always like maintain like the parity that you're currently at, and so you have these pairs: one n plus one, two n plus two, and so forth. Um, and then if like the parity is like one certain way, then you'll put the n plus one. You'll put the second number first, and the first number. And then if the parity is like another way, then you'll put the first number and then the second number. Because then this will, because like the XOR of this path right here will be equal to like something smaller than n. Then this thing will be wait, what will the XOR here be? It'll be equal to something smaller than n, right? And then wait, no, never mind. I don't think this construction works. Stupid. Wait, no. It should work. It should work. No, it does work. I don't know why I doubted myself. Um, yeah, the XOR of this thing is 1, right? So in general, it'll be x and then paired with n plus x. So the XOR of this thing is going to be what is x. The XOR of this thing, because this thing is x, the XOR of this thing will be 0, and then the XOR of this thing is going to be, let's say you have y and n plus y. The XOR of this thing is going to be what's it called? You flip the order, so the y comes first instead of the n plus x. The XOR of this thing will be y, and the XOR of this thing will be n. So that, and then by induction, you can see that if you extend it longer and longer, it'll work. Oh my god, what a tragedy. Anyways, I guess I'll just implement this quickly and then go to sleep. If I hadn't spent 40 minutes on B, why did I spend 40 minutes on B? Such a tragedy. Oh wait, you read an integer P. And then n is equal to this thing, right? And then oh right, I didn't look at the input format, or the output format, I mean. Images are numerated in the order of their appearance in the input data. It's kind of annoying. It's the chosen value for the ith node. Okay, so the node input output is, but we probably want to store the, like, the And I see each edge. Oh, I can't do this. We want to like counter thing set to 1 initially. Oh, and we care about some like parity, I guess. Print the chosen root. Um, sure, why not? This works. Besides E and minus 1. Um, we want to sign some stuff, so also v of 0 should automatically get what? The value should be n, right? Okay, so let's say we pass in parity equals 0 at the beginning. In our construction, we want to the first one should be what's it called? The first one should be n plus x and then x. So we want the larger one first. So let's say if not parity, then let's swap a and b, where a corresponds to the value of the edge and b is the value of the vertex. So we have I is equal to a is the value of edge, and oh my god, I can't call this a v because I usually call the like child vertex v here. Vval, eval. Oh god, I feel like this name is bad. It's fine. And then we v per parity flips, and then we print out the root, and all the values of the vertices, and then all the values of the edges, right? Is that the format? Vertices, and then edges, yeah, and then root. Oh yeah, that should be it. Implementation is pretty short, I guess. Fuck. Oh my god. Cry. What did I do wrong? Oh. Vval. Wow, I'm good at programming. Oh, all this is because I passed in the extra, like, parity thing, and I didn't update the parameters, I guess. Okay, I mean, it's gonna spit out some numbers, but it'll be completely impossible to tell whether it's correct or not. What was I saying?
Ah, you hate to see it. Oh, okay. Apparently, I don't know how to write DFS, and wait, actually, what on earth? How could? Yeah, apparently, I don't know how to write DFS. um, yeah, current, and then previous, and then the parody. Huh? I'm like very confused. Oh man, what is wrong? Hmm, well, I don't know what else to do. I mean, this is gonna print out a lot of stuff, I think, but sometimes. Oh, I fucked up. No, one. Wait, what? Read. Huh? Hello? If. I mean, this is the only part where it can. Oh, it's because this n is supposed to be an n minus 1. That's why. I think that's the only issue. Why did I put an n there? So that's such a strange like mistake. Like I know like oh I forgot to give me incremented counter so it like goes on to the next pair, right? I mean, hey, why is there a 0 here? Did hmm. Top 10 mysteries of the world. What? Are you okay? So we have an integer x. X is positive. I believe that both x and x plus n are non-zero. What? No, I know my solution is correct. I just can't program. It's too hard. Oh my god, it should be v file of v. Why is there I there? Maybe I'm just too tired or I'm rusty. I really don't know. Well, spending like 40 minutes on B would imply that I'm pretty rusty, I guess. 4163527. I mean, like, seems like my implementation might be correct. Who knows? Alright, yeah, let's submit. And I guess either this will like wrong answer on test one or Or I mean, it's pretty likely that I'll run ASR test one, because like unfortunately some problems like this one, as nice as they are, they're just like not they're not like intended for like a human to like look at the sample input and check whether it's correct or not. Okay, good. Yeah. I mean, it's not that hard, I think. Wait, did geothermal actually only solve 3 problems? I think I think maybe my E took like less time than my B did, which is like kind of cursed. Let's see. Assuming that I like started reading E like right here, it took me 16 plus 27 minutes, which is 43, right? I can't. 16 plus what was the number I had in my head? 16 plus 27. Right? Yeah, for 43 minutes on E. Um, and then like 39 minutes on B, which is like, oh, I don't know, it's so terrible. Anyways, I'm tired now and I'm going to go to sleep. Good night.